Afternoon, everybody. I hope you guys are well. Just checking, can you guys actually hear me? Because I had some issues with the chat last time. That would seem to be a positive. Okay, awesome. Right, well, good to see you guys. In this lesson, we're going to be looking at errors and testing in programs. Syntax error versus logic error, and then how you find those errors, how do you test them to get them out. I've actually made a little video on this that's already on Moodle, so some of you might have seen some of this stuff already in action. But it also would give us a great opportunity to have a look at pseudocode and get us back into the swing of looking at pseudocode and figuring out how it works. And welcome everyone. So errors and testing. Most of this lesson, by the way, will be actually you doing some activities and looking through the worksheet and looking at pseudocode, because actually there's not that much content. So we've got to be able to create a test plan. So how do you properly test for errors that might be on an algorithm? Be able to look at the right kind of data to do that effectively. And so the different types of data are normal data, so data you expect it to have. A boundary, so we're out on the edge, and we'll look at that. And then erroneous, so that's stuff that it shouldn't be getting, and how does it deal with it? And use trace tables, because we've looked at trace tables, to trace through a program. Okay. So, if you remember, there were two different types of errors: syntax errors versus logic errors. And as a recap, syntax errors are where you get those sort of red squiggly lines if you're using an IDE, and when you go run, it just doesn't run. The syntax errors means you're not following the rules of the programming language. So for instance, that could be that, you maybe needed to use, you've got a variable like name, lowercase n-a-m-e, and then over down you've used capital N. And it goes like, well, that's not the same variable, I don't understand. Or if you use an if statement, there should be if, and then in the brackets there should be a logical test, and if you don't put one there, it will be a syntax error. So like I say, syntax errors, when you make a mistake with the syntax error, the program just doesn't run. Whereas logic errors, she's looking happy because she's not made a syntax error. The program run, hooray, it works perfectly, but you can get logic errors. And logic errors are where the program runs but doesn't do what the programmer intended. Yeah, I know. Well, I got this from Miss Forvito. She went to grammar school, so I always said, I was always very jealous saying it, and so she got me this when she left, so I think it's quite appropriate to wear. Anyway, logic errors. The program runs, but it doesn't do what you intended it to do. So what can that mean? So like when you see a glitch in a game, so where maybe there's a wall and you can glitch over it or something like that, right? That's not a syntax error because the program's running. That's a logic error because it doesn't quite do what you meant to do. And the successful test is one which uncovers an error. Normally errors are really bad news, but in this one, anybody can come in right now. I've removed lobbies. Is Salman in the other? He's in this group. Is he in this group or in the other group? He's in this group, right? Yeah, he's, well, I've got a whole bunch of people here that say they're in another chat. Let's go invite them all in and see what happens. Let's see what happens. Anyway, so logic errors are where the program runs, but it doesn't do what you intended. And actually, logic errors are the harder ones to find because they can be absolutely fine and you just wait for a certain thing to happen. For instance, let's say you have an algorithm and it's doing it based on your mark and turning it into a grade. And so it says if you've got, I don't know, 80% or more, that should be an A, a grade A. I know we're looking in numbers now. But you've written it wrong. So actually it says greater than 80. So if somebody puts in 80, it actually gets you a B rather than an A, because you've written it wrong. You should have said greater than or equals to. So that would be a logic error. And of course, until somebody gets that result, you don't notice. And sometimes a long time can happen, and the mistake happens for a long time, and then it becomes clear, oh, we made a mistake here. So this is why we need to do testing, to look for logical errors. Okay. And so we have to figure out what's the right data to put in there to test it out, and how many different tests we're going to do. So we'd have to test for valid, or normal data, erroneous, so data that's not what it's expecting, and boundary, right on the edge. And so yeah, these are the things that we want to check. So we want to feed in normal data, erroneous, and boundary. So in this instance, we're expecting the user to enter a number between 1 and 100, okay, between 1 and 100. So we've got any value between 1 and 100. Can anybody give me an example of what normal data would be for this? So that you're testing to see, does the is it putting a number between 1 and 100? What would be an example of normal data? So 68, thank you, Brooke. So 68 will be an example of normal data because it's sat in between it. Can you example of erroneous data? Who can give me an example of erroneous data? So that's data that is not expected. So an example of that could be, for instance, oh, well, I'm inviting him in. What does it say? What does it say when I invite him in? Is it, well, is there some kind of message or? Yeah, I've just invited them all in. I've also invited like Hattie and Louis and a bunch of other people. Looks like Louis is actually in now, maybe? Both meeting. Is there another meeting somewhere? Oh, is it the meeting that happened in the past? Maybe I've given the wrong link. Guys, you stay here. I might have given a link to one that happened last week. So you guys stay here. Okay, I'm going to drop out and I'm going to go get the other people, okay? Okay, wicked. In fact, Louis, you would be a really benefit to me if you could drop out super quick. Go tell them that to go onto this one, to go onto the channel. Thank you, Louis. That's absolutely super helpful. All right, okay, so yeah, sorry for that, guys. Let's go back to doing this then. So that's my fault. So, but it's fine. This is all recorded on YouTube, so you'll be able to go back and look at it. So normal data is data that fits between 1 and 100. Okay, so that would be 68 would be example, and you could have 5 in the example. Erroneous data is data you're not expecting. So the example could be 104, or even potentially things like 4, but written as 4, because your end user might say, okay, please type in a number between 1 and 100, and they type in FOUR and hit enter. So that would also be an example of erroneous data. Let me just check if people are back. Guys, I'll have to end up putting you on mute if you guys keep talking to each other in this way. Please don't make me do that. Thank you, everybody. Anyway, let me just go onto calendar and see what the deal is. Right, so weird. I don't know. So weird. I don't know what the issue is. I'll try inviting again. Did you get them to come over, Louis? Oh, okay. So hopefully maybe we're on the right track this time. Like, I invited you to this chat. Did you get my invite? Okay. I sent an invite, a request to invite to you and a bunch of other people. How did you know to come here? Did you go like, oh, maybe I'll look at my calendar or something? Okay. So basically, the link on Show My Homework is linked to the wrong meeting. Bugger. All right. Sorry about that, people. Anyway, let's get back in here. So we're testing for logical errors. We're saying the user should enter the number between 1 and 100. Normal data, 68, 5, that's normal, that fits inside it. And it should accept it. But if I put erroneous data like 104 or 4 spelt like a 4 with letters, that's erroneous data. Anybody remember what the third type of data was? Anybody know what the third type of data is? Boundary data, exactly right. Borderline or boundary data. Now, boundary data is actually a very important test. It tests on the edge of where it's still valid. So in this case, what number should I use to test the boundary? Give me a number. Thank you, Brooke. That is really a good answer. Technically, what you go is 100 to see if it's right. What you could do actually is also go testing 101. So what's happening here, Zara, is we're saying we're writing a bit of code and it gets the person to type in a number between 1 and 100. And in theory, it rejects anything that's not between 1 and 100. What we want to do is we're going to have to throw it numbers to see if it actually works. So if we're using normal, it should accept, some examples could be 68 and 5. Erroneous data will be data that it shouldn't accept because it's outside of it. So examples of that would be things like 104, because that's greater than 100. Or writing 4, like typing FOUR should also not work. Boundary data is right on the edge to see whether you've done it correctly. So 100 or 101, or alternatively 1 or 0, because it's right on the edge of that boundary. So normal data, which is in between 1 and 100. Data on the boundaries of the valid range, so 1 or 100. So yeah, I mean, if I was going to test it, I'd include the 101 and the 0, but technically it should just be on the valid side. So it should be 101, 100, and the number 1. And invalid or erroneous data, yeah, 247, ABC, stuff that it shouldn't accept. Trace tables we've looked at before, so you trace a variable and then you keep tracking it to see where the problem actually is. And that's the new knowledge for today. What I'm going to do with you is I'm going to go through this. This is the worksheet on that you've got to do for today. And it's a really, really good opportunity to recap programming. If you can't see this, because it's not very sharp, YouTube is up, and I'm sure the YouTube stream is much better. I've actually made it public, so if you just go to my channel, you'd find the link right there. So just go to TLDR Computer Science, and then you'd find the link. Let's read it through. The pseudocode problem shown below, so here, is intended to model the calculations of the toll charge for crossing a bridge on a motorway. Between 6 a.m., which is recorded as 0600 hours, and 10 p.m., which is 2200 hours, inclusive, so it's inclusive of 600 and inclusive of 200, i.e. it's not 6001 to 2159. The charges are as followed. So this is what they get charged at that time. After 10 p.m., but not including 6 a.m., there is no charge. Amanda writes the following algorithm. If time is less than or equal to 6 or greater than or equal to 2200, so before 6 a.m. inclusive, or greater than 10 p.m. inclusive, then charge equals 0. And then, if it's not in that time, it tells you what all the charges are. If the vehicle was 1, which is a motorcycle, charge you £1 or £1 or 100. If it's a motor vehicle, if it's 2, then it should be a car, etc., etc. Doing this all on the same sheet is going to be mighty difficult. Let's see if I can just do something to make this a little bit better. Wish me luck. Okay, that's not perfect, but that's the best I'm going to make it. What I'm going to need is, if you really can't see that very easily, and you probably can't, is to go onto YouTube. I'll send you the link again. In fact, I'll send you the link this time, so in case there's any issues. Because that will be a much higher resolution version, because what you're going to have to do is you're going to have to answer these questions in your book. We're looking at this algorithm, and we need to figure out how to test it. So test number 1, and the data vehicle type number 1. So I'm testing data vehicle 1, which is a motorcycle. I'm saying I'm testing at 12:45, so that's between 6 a.m. and 10 p.m. It's a valid time. In fact, we should say normal. Because remember, there are 3 types. There's normal, erroneous, and borderline or boundary. So number 2, I'm testing for my second test. I'm testing for number 2, the second vehicle, which is a car. I'm testing at 6 a.m. What kind of a test is that? Is that a normal test, erroneous test, or a boundary test? So testing at 6 a.m., is that going to be a normal test, an erroneous test, or a boundary test? What do you reckon, guys? I don't know if anyone actually is responding. I had some problems with my chat earlier, but then it seemed to work so far. I'm asking you to just speculate. Do you think it's a normal test, a boundary test, or an erroneous test? This is testing to see at 6 a.m. Clarice, thank you very much. Completely agree with you. In fact, because of your commitment so far, I'm going to give you a good student mark. Thank you, Clarice. So Clarice is saying he thinks it's a boundary test. And if you look at it, it should be that between 6 a.m. and 10 p.m. inclusive, which is what it says here, it's a bit small. So we're testing right on the edge to see if that actually works. So we're saying it's a boundary test. What is the expected result? So we're saying for vehicle number 2, I don't know if you can see that, it's a bit small. For vehicle number 2, a car, it's saying that it is between 6 a.m. and 10 p.m. It should return 2, so £2. Right. Thank you so much, Louis. For some reason, my chat is all over the place, but I can see it there. Louis suggesting it's a charge of 0. Louis, that puts you on the good persons list. Thank you, Louis. If you can see here, if time, in this case time is 0600, is 0600 less than or equal to 0600? Yeah, it is. And remember, with an OR, you only need one of these to be true, so your charge would be 0. So we've actually just discovered a problem, and the solution would be to say it's less than 6 or greater than 10. So we shouldn't do greater than or equal to or less than or equal to. We've done a normal, we've done a boundary. Should we test the other boundary? Yes, we should. So I'd say we could test another vehicle, like number 3. And what would the other boundary time we should test to be? What's the other boundary time? What do you reckon, guys? What's the other boundary that we could be testing? Thank you, Clarice. Spot on. Yeah, sorry, we will do erroneous in a moment. Thank you, Josh. That is very kind of you as well. So at 2200, we want to test the other boundary. And again, so with we should include here that the expected result should be, because it's cast number 3, it should be £2.50. But if we look at it, 2200, is 2200 less than or equal to 600? No, so that would be false. But is 2200 greater than or equal to 2200? Yes, it is, so that would be true. In which case, again, the charge would be 0. So we've just discovered, yeah, that there's an issue on the other side. I'm with Syra. The last one we'll do here. So let's answer the last one. Let's do erroneous. Right. There are 2 different ways we could do erroneous. Right? There's 2 different versions. Can anybody suggest to me what some of the inputs you can give in? I mean, more than 2, but can you give me some suggestions about some of the ways you could do erroneous on here? Any suggestions about how we could do erroneous? So these are things that are not valid, things that shouldn't expect. So not on the boundary, things that are invalid. Any suggestions for erroneous data we could give it? So it's basically in this box and or that box, erroneous data. So yeah, we could say 0100, we could say is outside the range. Yeah. So that's erroneous. I mean, that's tricky to know in this context because it's catching it, but it's worth knowing. And you to say it should be 0, and it actually is 0. How about this one, though? This is true erroneous. How about if I put 10, and then here I put 1. So I've put 10 for the type of vehicle, and you can see there are only 4 vehicles, so that would be erroneous. And the value 1, but I typed it in 1. Expected result for change, we don't know, right? What's going to happen? Well, is the time 1 greater than or less? No, that'd be false. It might be the charge is 0. Hopefully, actually, yeah, we'll get a charge of 0. But it might be that actually responding, you think about it, the data types, suddenly getting a string when you expected an int would probably make the whole thing fall over. Okay. Then the next question underneath, it says, is the logic of the program correct? So this is when you could talk about on here that instead of less than or equal to 600, it should be less than 600 and greater than 2200. And then we've got another one, which is a flowchart. And then use the flowchart to describe the rules of the game. Here's what I'm going to do. I'm going to get you guys to have an opportunity to have a go at those questions. So if you go to assignment, on your Teams, you'll see that there's a new assignment in there called Errors and Testing. If you click on there, I've associated the PowerPoint, but most importantly is the worksheet. You can type in the tests that we just talked about for task 1 and how to fix it. And then I want you to have a go at task 2 by following the flowchart on there. Would you find it helpful, guys, if I just talk through the flowchart quickly with you, or are you happy to give it your shot first? So do you want me to quickly try and talk through the flowchart, or are you happy to attempt the flowchart yourself first? Okay, so we've got a happy from Louis. Are we all happy in that situation? Because I'll be monitoring your work then, obviously, to figure out your attendance attempting it. So, oh, okay. Okay, well then give me 1 sec then. I won't talk through the whole thing, but I'll get you started. So, first thing you want to do is, obviously, we want to do what we've just done here. And if you're not too sure what I just talked about, you can go back to YouTube, rewind, and you can get it that way. Task 2 here, well, it's essentially asking you to use this flowchart and then figure out what it actually does and then write it down. So James is writing a program to simulate a dice game. The function random 1 to 6 creates a random number between 1 and 6. So if you see here where it says random 1 to 6, that means that die 1 could be 2, 3, 4, 5. It's a number between 1 and 6 randomly. He has drawn a flowchart to represent the algorithm to calculate a player score when it's their turn. And so that Paul and Colleen are playing the game. So if you remember, you always start at the start, and then the rectangle is a process to doing things. So die 1 is rolled, die 2 is rolled. The diamond, that's a decision. Are they equal to each other? So if you've rolled a 4 and a 4, if they are equal to each other, then you don't get any score at all. So you get 0. If they're not equal to each other, score is equal to score plus die 1 and die 2, and then you have another go. So you'll basically keep rolling. Maybe I've said enough. Yeah, I've probably said enough. So you'll need to describe that game here and then follow the rules. Then that's the pseudocode of it. And you've got to judge whether you think that's right. Now, I'm not saying this isn't challenging, but you guys need to have a go at it. So on your sheet, first thing you're doing is you're having a go at that. And like I say, if you're not too sure, you can go back and look at the video. Then you're going to need to describe how that flowchart works here. So how the game works. Underneath it, then you'll read that and action this. And then we'll be on to task 3, which is a bit more pseudocode. I'm going to give you 20 minutes. I'm going to go off mic now, so you have the opportunity to do that. Give you 20 minutes, and I'll be monitoring your worksheet. Most of the recording I'll do then of like attendance and then who I think is doing really well today. That will be done based on the worksheet. And how much you're actually using that. Nope, you don't need that. You need that. So I'm going to go have a look at your attendance. Have a look at your worksheet. If anybody isn't too sure where to find the worksheet, of course we've been doing this every week, but you can let me know. And what do we agree? We agree 20 minutes to get task 1 and 2 done. Louis, was Lewis Clark and Haddie in this other group? I'm saying do tasks 1 and 2 for now, Brooke, but if you can do tasks 3 and 4, you should totally do so. Oh, Haddie's actually here now. You hear me, Haddie? Hattie, it'd be easier if you were here on time. All right. You now can follow the video on here. I've been recording the session. If you go on there, you can get caught up about what we're doing. And like as before, I'll do the attendance based on, you know, your engagement on the activity. Okay, Hattie? Yeah, good point, Louis. Yeah, you were in the wrong place, Hattie. Well, it's on me. Who else was waiting with you? I suppose you couldn't see because you were in a list. Abdul's here now, though. So you can go onto the YouTube stream to go get caught up on what you need to do. Right, so Lewis is missing. Chris is missing. Give me one sec, Brooke. I'll have a quick look. Brooke. Brooke, can you see your work shared? Right, wicked. So, what it's saying is that A, as in the number, like you say, 7, and then A midpoint is what's stored in the array at that point. So, Ken, I guess in this case. Make sense? Wicked. Hey Zara, you got the same issue as before where you can't actually do it because you're on your phone, so you can't do the worksheet. Okay. What do other people not do assignments the same way? Because I think you're going to find a lot of people are going to start doing assignments. So, what did we do last time? Did you do it and didn't you do it and then you took a photo and sent it to me? Like, can you access the sheet, Sarah? At least, can you look at it? Hello, Alfie. Did you just drop in? Alfie, did you just, because I just seen your name come up, I wasn't too sure how long you've been in here for, Alfie. You hear me, Alfie? Okay, great. Did you just turn up, Alfie? As in, do you know what you're doing? Or is it you've just turned up? Do you know what you need to be doing then for this lesson? And are you aware of the, you can go to YouTube and, okay, so I've been recording the lesson on YouTube, so you're welcome to go onto that to do a recap if you're not too sure. So if you go on there, you can see the lesson and skip ahead to the, well, you can probably skip the intro, but you can get to the bit you want to be doing. And then it's the assignment that you should be doing. I think Hadi must be doing that right now. Is that okay, Alfie? Syntax errors are where you get those sort of red squiggly lines if you're using an IDE, and when you go run, it just doesn't run. The syntax errors means you're not following the rules of the programming language. So for instance, that could be that, for instance, you maybe needed to use, you've got a variable like name, lowercase n-a-m-e, and then over down you use capital N. And it goes like, well, that's not the same variable, I don't understand. Or if you use an if statement, there should be if, and then in the brackets, or more, that should be an A, a grade A. And I would mean numbers now. But you've written it wrong, so actually it says greater than A, wicket. So that would also be an example of be things like 104, because that's i.e. it's not 6. My chat is all probably make the whole thing for I agree with you, Hussein. If both die the same, you score 0. If not, your score is the total of both die. But you also want to talk about the fact that you can have another go, and it will keep adding to the total. What? As in you can't click on the link? Oh, let me get the link again. It's just a YouTube link. Obviously it's live, so you'll need to scrub back to the beginning, Alfie. Are you at school? Or are you at home? Sorry, Clarice, I'm not ignoring you. I'm just Alfie saying you can't click on that link, or it says it's unavailable, which I don't quite get because maybe it's blocked on. Maybe YouTube's blocked. Have you been on YouTube on that thing before? That is really annoying. You know what, Alfie, then, in like a few, well, how long we got now? In 6 minutes, I'm going to be going through the answers. So I think in fact, maybe it's too long because people are getting through this quite quick, actually. Let me check out yours, Clarice, then. So, Clarice, is it you're struggling to figure out how the game works, basically? Because like the flow chart basically describes it, and then you got to try and attempt it. You got to explain how the game actually works. All right. You know what I'm going to do then? You might be representing a few people. I'm going to pause there, and then I'm going to go through how to actually answer that question. Let's go on to the next thing, because otherwise time's going to get away from us. So let's go back to looking at our problem, and let's see if we can get any closer to getting an answer. So let's review the flowchart again. So that's our flowchart. Maybe let's contextualize it. Let's put Clarice into the game. So Clarice and Alfie are my two players. Okay? So you guys are playing in this game now. Oh, sugar. I haven't put my camera on. One sec. So Clarice and Alfie are now both in the game. Clarice is going to go first. He rolls die number 1. So maybe down here, if I put this to the side. There you go. So I'm going to have die 1. So that's basically dice number 1 and die number 2. Okay. Clarice plays the game. First thing that happens is he rolls the first dice. 1 to 6, and he rolls a 4. And he rolls another die, and he rolls another 4. All right, Clarice, check this out. Does die 1 equal die 2? Yeah. It says yes, so your score is, your score is 0. Output score. So your score was 0. Bad luck, Clarice. Now Alfie's going to play the game. And he rolls the first dice. And he rolls a 5. And then this time he rolls a 4. Is 5 equal to 4, Alfie? is die 1 equal to die 2? No, exactly. So it's going to come down here and it's saying score equals score plus die 1, die 2. But this time, the question is, here's an issue you might have, because score is not refreshed. I guess we have to assume it starts at 0. We'll say 5 plus 4 plus 0, so score is 9. So score equals 9. Do you want to have another go, Alfie? Right, do you want to roll the dice again? Brick it. Here it goes. Rolls it again. You rolled a 3 and a 2. Die 1 and die 2 are not equal to each other. So score, which is 9, plus 3 plus 2. So score is now 14. Do you want to have another go? What's he risking? What's he risking in this game? Like, what could he do? Yeah, but what's he risking? If he goes again, what's the thing that could happen that could get rid of his score? Okay, I'll explain it then. Every time you're going around, you're risking getting 2 dice of the same value. Because he's up to 14 now. He goes again. He rolls a 5 and a 5. Boom, suddenly his score is 0. So you're kind of, with each other, sort of gambling whether you're going to get at what point to stick with your score. So that's the idea. You keep going around until you want to stick with that score. But if you gamble and go too far and get a bit greedy, then you can get 2 the same and then you won't get a score. That's how the game's worked. So in here, it just says, Paul rolls the dice 3 times, getting 6 and 2 on the first throw. All right, so you got 6 and 2, 1 and 4 on the second throw. So 6 and 2, 1 and 4, and 2 and 3 in the third throw. So his score will be 6 plus 2, and then it will be plus 1 plus 4 plus 1 and 4 on the second throw, and 2 and 3. 2 and 3 on his third throw. Okay? So 8 plus 5 is 13, plus 5 is 20. Okay? So Paul's got 20. Colleen rolls the dice 3 times, gets a 5 and a 6. Oh, wow. Big score. Plus a 4 and a 6. Big score again. And then a 2 and a 2 on the last throw. People, for what was I saying? For Colleen, what score is she going to get? Thank you, Claire. It's exactly right. So she had 11, then she had 21. If she'd have stopped there, she'd actually have beaten Paul. But on that third throw, she got 2 2s, so it actually gets a score of 0. And then we can look here. James has tried to rewrite it, but instead of using, remember, you can use flowcharts or pseudocode. They've used a pseudocode instead of the flowchart, but it doesn't work correctly. So there's a fault somewhere here. Can you correct for him by inserting one more statement? So somewhere in here, there's a fault. In fact, I'm going to leave it up there for a couple of minutes for you guys to actually look at it and see if you can spot what the actual fault is. Okay, so you've got 2 minutes to look to see what you think the fault might be. Well, Clarice, I'm going to give each other another 90 seconds, give you the time to think it through, and then we'll talk about it. Okay, guys. So that's a suggestion. I see that, Clarice. She forgot the end if. Well, on here, this if, else, end if, all of that, that's one big if statement. That's one if statement together. So you don't need to if, the end if, then else. That if and that end if are together. So no, that's good. Any other suggestions, guys? Any other suggestions? Come on, don't be shy. Well, let's review. So it's a repeat until loop. So that will keep going around until the answer is going to be no. So that kind of makes sense, right? Because that's the you want another go question. Right. Okay, Josh. Thank you, Josh. I'm going to add you to the list of good people. You might have already been on the list of good people, but you're doubly on it. So, yes, this bit makes sense. The random number. So, in fact, why don't I just do this? So this bit makes sense. Generate a random number. Generate a second random number. If they match each other, then score should be 0. Fine. If they don't match each other, then add die 1 and die 2 to score. Yeah, agree with you. Ask if you want to have another go. And then if you said yes, you go again. Is yes, that's no. But the issue is, it's like, if in here, if in here the score is 0, then you, so let's say, if you've got 4 and 4 as your two dice rolls, then they'll be equal to each other. Score set to 0, good. Then you come down to the end if. Is the answer no? No, it isn't. So it would ask you again. So what you'd have to do, so you could set answer no here, or at the beginning of every loop, like in here, you could say answer equals no. And so the statement means that as you go along, you're automatically going to be terminating the loop unless you get to this point and they say yes. Technically, this is a little bit broken as well, because you could say, if you said, for instance, for answer, if you put down answer, so for the input, and you put in Bob, oh no. So let's say you've gone down here, you rolled a 4 and a 6, and then you wrote down for your answer So you got 4 and a 6. It started telling you score. It asks you if you want to have another go. So it's expecting you to put in a yes or a no, and you put in Bob. Question, guys. What's that going to do if I put in the answer Bob? Is the loop going to terminate? Because I've not put in yes, I put in Bob. So what happens then? Yeah, it will carry on because it's only looking for the answer no. So anything that's not no, you could put down like literally anything you want and it'll just carry on as it goes along. All right, people. So let's have a look at task 3, and this is the what we'll be doing towards the end at the end of this lesson today. Good recap, because we'll have a look at sort an array of names into ascending order. So if you remember, the two sorts we've looked at are bubble sort and merge sort. So it's going to be using presumably one of those sorts. We've got an array of all the items and they're unordered. The number of items is 6. While the number of items is greater than 1, and there's 6, so 6 is greater than 1, count from 0 to 5. So remember, in an array, that would be 0, 1, 2, 3, 4, 5. If username at count, so count at 0, so if username at 0, which would be Carl, is greater than the username at count plus 1, so it's greater than Tasmin, then we'll swap them around. Which sort are we doing right now? Bubble sort. Well done, Josh. Well done, Clarice. It's saying it doesn't work. So there's a fault. You've got to say the type of error. So it's either a logic error or a syntax error. And then how to fix it. So I'm going to give you, let's say I'll give you 4 minutes. You can have a go at actually doing that on your paper. And then we'll be able to go down to this next one here. So you've got 4 minutes to attempt this question here. So you've got 4 minutes. Yeah, Hattie, I don't know if you're listening or not right now, but you haven't even attempted the paper, so you need to actually attempt it for me to be able to register you. So can you please actually go on to the, I know you were late to the lesson for reasons that weren't totally your fault, but you got the YouTube link a long time ago, and I asked you to then attempt it. On task 3, Hussein? You can't quite see what the problem is. That's fine. Well, like I say, we've only got 4 minutes to give it a go. And then we'll go through it. How do you find it? It's in assignments, Hattie. Let me show you. So in here, you go to your teams, you go to assignments like you've done in your previous lessons. Errors and testing is the one that you're doing, so click on that. Scroll down to yours. Well, yours won't be scrolling, it'll just be yours. When you click on this, you'll see a Word document. Click on the Word document, and then that's your work to do. Okay, honey? Awesome. Yeah, no worries, Hussein. In 1 minute, I'm going to actually go through it and see if we can identify the issue. In fact, I'm going to start prepping. Right. So I'm starting to do this, but I'm going to actually type it because then I can fit it on a little bit better. Yeah, that's on. Okay, good. So let's forget that for a moment. I'm going to start creating a table. What kind of table do we use to find an error? We were talking about it earlier. So I'm going to record the key variables. Truth table is so close. I can see why you're saying it, but a truth table was for logic gates. So it's very close to truth table. Remember, truth table is when you had different logic gates and you wanted to figure out the true and false to see which one the actual logical circuit did. This is very close to truth table, but it's not. It's another word beginning with T, in fact. So it's one where you identify all of the key variables. Thank you. I think that's you. Is it Salmon? Oh, it's weird. My phone is out of sync. Yes, but trace table is right. So I've got, in fact, can I change that to green? Count. Sorry guys, this is taking me way longer than I wanted. Right, let's try all this again. My apologies. Just because I'm trying to fit it all on, and if I use my normal handwriting, which is big and not that clear, you won't be able to see. So we've got that up here, then we've got here, and put in here, start my trace table. We'll make it, come on. Sorry, I'm getting frustrated with the computer, which is not super wise. So we need to keep track of the key algorithm, of the key variables. We've got count. What else we got? We got so count is one. Number of items. There you go. That's another key variable. So the trace table, we need to trace all the key algorithms. And then we could say username count put that here, and then we'll do oh no, there's actually quite a few variables here. Temp, I'm going to shorten this. Oh, I can't really shorten it because then it won't make any sense. Oh, and now it's not even on the, oh, flip. I have to make it smaller, sorry guys, like that. Temp, and then we've also got username, oh, we've also got username count +1. Sorry for the delay, guys, but it's really worth, I think, my while doing this because it gives us an opportunity to actually look at all this. And then so this is the trace table. How does it work? We trace, you're definitely going to want to look at YouTube on this. This is looking pretty small. We want to basically follow the algorithm and trace the variables as we go along. So in this case, number of items starts off as being 6. So I'll write in 6 for the number of items. Count was 0. Username at count. So that would be this one here, it would be Carl. Username at count +1, so that's Tasmin. And then it says, is Carl bigger than Tasmin alphabetically? And it's not. So we can skip that logic here, end if, and then we'll go count for the next one. We'll go count 1, and we'll say number of items is still 6. Username at 1 would be Tasmin. And then the next one will be Eric. And you can see T is higher than E. Sorry, is it saying Tasmin is higher than Eric? So what we should do is store temp, should be username count +1. So that should become Eric. And then username at count becomes username at count +1. So that's because username at count becomes Eric. And then that becomes Tasmin. So we just swapped it over. You know, and it will keep going for a while. But unfortunately in here, eventually we're going to get to an error. So as we're going along, this is actually working okay, as in Tasmin and Eric should have swapped. And then Zoe will stay. Yeah, Zoe will swap with Tasmin, so they'll swap. Alan will go there. I think what's happening though is that the number of items -1 is that as we're going along, do you see the issue that we're going to get at the end? Let me put it bigger so you guys can see it more easily. I don't know if that's much easier to see, but as you go along, what's going to happen eventually is Alan is going to get put to the front here. And can you see what the reason for that might be? So we've only got like 3 minutes left. So now that we've gone through it a little bit, I'll give you another 2 minutes. See if you can think out what the reason might be. And then we'll finish the lesson by going over that. Oh no, we're last minute, right? Okay, guys, I'm going to pause, and then we're going to just do this last bit here. I've just rubbed those bits off because I think it's worth us going over actually what happened again, because I've described it poorly here, so my apologies. Temp, so where were we? We were saying that user count is, we've got Tasmin and Eric. Thank you, people. Thank you, guys. So we've got, we had Tasmin and Eric, and we're saying Tasmin is bigger than Eric. Temp became username plus 1, so that became Eric. So we're temporarily holding Eric. And then underneath here it says username count here becomes username count plus 1. So that becomes, so actually we'll swap it. So this one over here becomes Eric. Whoops, I was using blue. Don't you worry, guys, we'll do this. So it's saying, you see here it says username count is username count plus 1. We're taking Eric and we're writing over Tasmin. Then we're saying username count plus 1, so this spot should be temp. So it should be Tasmin, but it's not. Temp is actually Eric. So Eric overwrites both of them. The way to fix it is here, you should actually just not, you should temporarily store count rather than count plus 1. So in temporary here, that should actually store Tasmin, and when over here, you'd actually come back Tasmin there. What kind of error is it? Is it a syntax error or a logic error? Did the program run? Did the program not run? So did the program actually, did it work? It ran, but it didn't do what I intended. So it ran, but it didn't do what I intended, and therefore it's a logic error. It's a logic error. Yeah. Thank you, Zara. Thank you, Zara. So it's a logic error because it ran, but it didn't do what I intended. Okay. Thank you very much, everybody. In our next lesson, we'll be looking at the different ways that we take our code like this and turn it into ones and zeros. It's called translators, or compilation and interpretation. So we'll do that in our next lesson, which is tomorrow, I think. Okay. So anyway, that's the end of the lesson for this. You got the 25-minute independent study time now. So it'd be a great opportunity for you to finish off this sheet. I'll have a look over it, and then we'll get on to compilation tomorrow. But for now, thank you so much for your time. Sorry if we had any logistical errors. And I know this is tricky to do online, but thank you so much for giving your best focus. And then tomorrow we'll continue. See you later, people.